Uh, Today we will discuss plane. What is plane and what is the condition of parallel of two planes or perpendicular of two planes. So we will discuss all those things because if we do not know the theory of plane, so we cannot solve a single sums from plane. So let's we discuss first the plane. Every equation of first degree of the form ax plus by plus cz plus d equal to 0. This is the basic equation of a plane which represents the equation of a plane. Okay, why it is first degree? Because power of x is here 1, power of y is 1, and power of z is also 1. So as a degree is 1, so it is a first degree. Okay, now ax plus by plus cz equal to minus d. If you bring d right hand side, so minus d. So this is equation number 1. Now coefficient of x, what? A, coefficient of y, b, and coefficient of z, c. So a, b, c are the direction ratios of the plane. Plane 1. Plane 1 means this equation of plane. This direction ratio of that plane is ax plus by plus cz equal to minus d. Now make it clear one thing, that direction ratio of the plane. So we cannot say the direction ratio of the plane because direction ratio of the normal to the plane. Suppose this is one plane, the direction ratio of plane, it doesn't means it plane does not have any direction ratio. If we draw one normal on the plane, so direction ratio of the normal, that is the direction ratio of the plane. Okay, so direction ratio of the normal to the plane, that is ABC. Now equation 1, number 1, if any plane passes through a point x1 y1 z1, if any plane passes to the point x1 y1 z1, so in place of x1 y1 z1, I mean 2 3 4 minus 1 2 minus 3, any one point, the equation of the plane will be a within bracket x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. Here a, b, c, these a, b, c are the direction ratio of that plane. Okay, next number 2, the equation of the plane which passes through the intersection of the planes. Suppose this is one plane and this is another plane. Okay, these two planes, they are intersecting to each other. If we draw one plane, I have drawn here straight line, but it is not a straight line, it is a plane. Okay, so if we draw one plane which is passing through the intersection of the planes, I have written two planes, a1x plus b1y plus c1z plus d1 equal to 0, and another equation a2x plus b2y plus c2z plus d2 equal to 0. So equation of the plane which passes through the intersection of these two planes is plane number 1 and plane number 2, that is first equation of plane plus lambda into second equation of plane equal to 0, where lambda is any scalar quantity, any constant or scalar quantity. So in place of lambda you can write k also, no problem. Okay, next number 3, angle between two planes. Suppose this is one plane and this is another plane. In each and every cases we have taken the similar type of planes because it will help to remember all those formulas very easily. Now a1x plus b1y plus c1z plus d1 equal to 0, and next equation of plane a2x plus b2y plus c2z plus d2 equal to 0. Now if angle between these two planes is theta, so cos theta equal to a1 a2 plus b1 b2 plus c1 c2 by root over a1 square plus b1 square plus c1 square into root over a2 square plus b2 square plus c2 square. Here a1 b1 c1 is coefficient of x y z of first equation of plane, and a2 b2 c2 is the coefficient of x y z of second equation of plane. So very simple formula, so you will memorize it. Next number 4, these two equations same. Condition of perpendicularity. What is the condition of this perpendicularity of these two planes? Coefficient of x here a1, coefficient of x here a2, so a1 into a2 plus similarly b1 plus b2 plus c1 into c2 equal to 0. So if the product of the direction ratios of two planes and sum of those product equal to 0, that means these two planes definitely they are perpendicular. Remember one thing, two planes are perpendicular means the normal of two planes are perpendicular. Okay, Condition of parallel. What is the condition of parallel of these two planes? Suppose these two planes are parallel. That means condition is E1 by A2 equal to B1 by B2 equal to C1 by C2. This ratio must be equal. If we can show that these ratios are equal, that means definitely given two planes are parallel. Okay. Next, equation of coordinate plane. Suppose this is x axis, this is y axis, and this is z axis. O is the origin. Now y o z plane, z o x plane, and x o y plane. Now see, y o z plane, that means this plane. This is also called yz plane. This is called yz plane. This is called xy plane, and this is called xz plane. Now, equation of yz plane is x equal to 0. Why x equal to 0? Because there is no x part. Okay, this is xz plane. Equation of xz plane is y equal to 0. Why it is y equal to 0? Because there is no y term. And xy plane means equation is z equal to 0. And of the plane parallel to the coordinate planes are, equation of the plane which are parallel to the coordinate plane, x equal to lambda, y equal to mu, and z equal to nu respectively. Now, perpendicular to coordinate planes, x equal to 0, y equal to 0, and z equal to 0, or you can say parallel to axes are by plus cz plus d equal to 0. Remember it. When x equal to 0, so there is no x part. Remember this by plus cz plus d equal to 0. If y equal to 0, then the equation of plane is ax plus cz plus d equal to 0. If z equal to 0, that means ax plus by plus d equal to 0. Now, intercept form of the equation of the plane. X by a plus y by b plus z by c equal to 1. If we draw a diagram, so x, it is y, and this is z. Okay, so it is a 0 0, this is 0 b 0, and this is 0 0 c. Okay, suppose it is a, it is b, and this is c. So equation of this variable plane is x by a plus y by b plus z by c equal to 1. Now normal form of the plane, normal form of the equation of the plane is Lx plus My plus Nz equal to P, where remember that L, M, N are direction cosine, which we have already learned in coordinate geometry. So there is a direction cosine, you will get the direction ratio of line, and what is the relationship between direction cosine and direction ratio, you will already learned in that chapters. Okay, now question, next question, next point is 8. Plane parallel to a given plane. Suppose this is one plane. If they are asked to write one other plane which is parallel to the given plane, so remember one thing, that coefficient of x, coefficient of y, and coefficient of z, it will remain same. Just constant part is changed. Here is d, and the parallel plane, this d is will be changed, d dash. Okay, only one change. And a coefficient of x, coefficient of y, and coefficient z of z will be same, remain same. Next, point number 9, angle between a line and a plane. Suppose this is one equation of a plane, a line, straight line, x minus x1 by l, y minus y1 by m, and z minus z1 by n. And another equation of plane is ax plus by plus cz plus d equal to 0. This is a symmetric form of plane, sorry, straight line, and this is equation of plane. If they asked to find the angle between the line and a plane, so cos 90 minus theta, complementary angle, cos 90 minus theta equal to a direction ratio with direction cosine of straight line l plus b into m plus c into n by root over sum of square of direction ratios of plane into root over sum of square of direction cosine of straight line, l square plus m square plus n square. Okay, next, number 10, distance of a point x dash, y dash, and z dash from a equation of plane ax plus by plus cz plus d equal to 0, that is ax dash plus by dash plus cz dash by root over a square plus b square plus c square. Whatever point they will give, just you will put in place of x in that equation by root over coefficient of x square plus coefficient of y square and plus coefficient of z square from equation plane. Okay, this is point number 10, and we will discuss last point. It is very important point: equation of planes bisecting angle between the two given planes. Suppose two planes are given, another plane, equation of plane which is bisecting the angle between that intersecting plane, that is the equation of that plane ax a1x plus b1y plus c1z plus d1 by root over a1 square plus b1 square plus c1 square equal to plus minus a2x plus b2y plus c2z plus d2 by root over a2 square plus b2 square plus c2 square. So if you know and if you can understand all those formulas, so you can easily solve the sums from the chapter plane. Okay, thank you.